hypothesis testing, and I hope that if you have listened me clearly, then you would have understood about the hypothesis basic. First of all, what is hypothesis, and after that, what are its different types, and now we have to move further for the different kinds of errors. This is again very important. So now I'm just going to share this. These are errors in hypothesis. Errors in a hypothesis. These are two types of, there are two types of errors only, okay? And this is known as type 1 and type 2 error. You would have heard their names a lot of time during your graduation and post-graduation and during the preparation of NET and JRF as well, I'm sure. And number of students would have skipped this topic simply because they never able to understand what's the real meaning of these two topics are. So null hypothesis, you have understood that completely. Somebody was asking me to give one more example. Just after finishing the class of that, I simply told him that if you think something, if you think that something shall happen, something shall happen, and if you assume that yes, it shall happen, you have belief in you, you have faith in you, not at least not for if 100%, maybe 90% or 95%, because there is always a probability of you yourself being wrong. If at that much level of confidence you say that yes, I am right, okay, this is null hypothesis. Null hypothesis, that means you are assuming what you think that shall happen, and that shall happen. Okay, so this is about null hypothesis. And alternate hypothesis, we never specify. It comes automatically into picture. That means if the null hypothesis is rejected, then ultimately alternate hypothesis is accepted. Now, I must tell you about the errors of hypothesis testing. Okay, there are only two types of errors. Okay, in the process of hypothesis testing, we come across some sorts of errors since there is every possibility. We can reject a null hypothesis which is a true, and we can accept a null hypothesis which is false. Okay, so these are the two lines important. Okay, in this table you shall be able to understand it better. Okay, if null hypothesis is true, when a null hypothesis becomes true, when you have applied tests like t-test, z-test, chi-square test, ANOVA, f-test, these tests. After applying these tests to your hypothetical statement, to your hypothesis, when you have come to the conclusion that your null hypothesis is true, okay, and you are accepting this also, when this combination is there, what I'm saying, understand this clearly. When after applying some tests to your hypothesis, you come to the conclusion that your null hypothesis is true, but mistakenly or knowingly or unknowingly, if you accept it, okay, because this is not in your hands. Why? Because you cannot 100% sure ever regarding any research question. There shall be rain tomorrow or not. You can never say 100% yes, there will be rain. You can only say 90%, 95% or 99%. 100% cannot. If something is 100%, there is no research. Then there is no question of research. Okay. If your null hypothesis is true as per the different tests and you accept it, then this is a correct decision of you. Correct decision of you. In case your null hypothesis is true as per the different tests of at your hypothetical statements, but mistakenly you reject it. Mistakenly, I'm saying mistakenly you reject it, because there are always a 5% chance. If you are sure 95%, then 5% chances are there that you can be wrong. If you mistakenly fall in that category, in a rejection category, then this is known as type 1 error, and this is known as alpha error. Okay, what I am teaching you, if a null hypothesis is true as per the different tests and you accept it, this is your correct decision. But if null hypothesis is true and mistakenly you reject it, This is a type 1 error. Okay, this is a type 1 error. Means you are rejecting a true statement. Now again, if null hypothesis is false, null hypothesis is false means as per the tests, different tests, Z test, T test, chi-square, ANOVA, F test, if as per these tests your assumption comes to be false, but still you believe, still you accept your null hypothesis, then this is type 2 error. This is known as beta error. And if your hypothesis is false as per different tests upon your assumption and you reject your hypothesis, then this is your correct decision. Okay, correct decision and errors. You have to understand these. They can ask you what is type 1 error, what is type 2 error. These are very simple. Now I hope you would have understood the complete idea and make into your mind. If null hypothesis is true, means null again think in your mind, null hypothesis was there is no difference between sample and population parameters, sample statistic and population parameters, there is no difference, none kind of difference is there. Okay, there is no difference, and what I am saying about my hypothesis, this is always right. Okay, this is null hypothesis, and if all these statement comes to be true and you accept it, this is correct decision. If all these statement comes to be true but mistakenly you reject it, then this is type 1 error. Again, if your hypothesis comes to be false but mistakenly you accept it, this is type 2 error. And if this is false and exactly you reject it, this is your correct decision. So these are two types of errors in hypothesis testing. Type 1 error denoted by alpha is an error which is committed through a test by rejecting a null hypothesis which is true. This is a rejection of null hypothesis which was true. This is why this is type 1 error. And what is type 2? This is denoted by beta. This is an error committed through tests by accepting a null hypothesis which is false. Okay, which is false. So I am accepting the null hypothesis which is false. This is type 2 error. So only these two types of errors are there. Why these error occurs? Because we are never sure about any hypothetical statements. We have to research it further. And one more thing, I told you that alternative hypothesis is never specified. Okay, never specified. It automatically comes into picture. That means if I'm accepting the null hypothesis, that means I am rejecting the alternate hypothesis. If I'm rejecting the null hypothesis, that means ultimately I'm accepting the alternate hypothesis. So this automatically comes into picture. And I think I forgot one thing. The null hypothesis is denoted as this H0. HO, some author says 0, some author says O. This is denoted as this. And alternate hypothesis is denoted as H1. This is all about the errors. Now we have to move further. This is about of tailed tests of hypothesis. Now the hypothesis testing is done on tails. Okay, tails you have already understood. I told you that you must be aware of the normal distribution before understanding this specific or particular topic. This is a normal distribution curve, and I taught you in a very elaborated and clear manner that mean, median, mode are at the very central level of the normal distribution, and it has two tails. This is tail 1, this is tail 2, this is left tail, and this is the right tail. Okay, so tailed test of a hypothesis is just specifying which tails are you using. Okay, some researcher use only this area for researching. They take only 50% of area of normal distribution. Some take 100% area. Okay, and that do not make any kind of difference in a research. Okay, you can take any. Okay, if we are taking both the tails into picture for doing the study, that kind of study is known as two-tailed test. Two-tailed test. And what is one-tailed test? If the researcher is researching from the point of view of only one tail, so that whatever the result of one tail comes, he can apply this to second as well. Okay, so this is known as one tail test, and that is of two types. This is left tail test and this is right tail test. So I hope you would have understood about these as well. Tail tests are not very difficult to understand. None kind of a practical or a numerical system is there to understand these. Only thing is normal probability curve having two tails, left and right tails, having a complete area of 100%. This makes this complete makes the area of 100%. 50% is area is covered by left tail and 50% area is covered by right tail. So these are about a tail test. I left this blank completely because I wanted to teach this at this slide, but I think everything is already clear right now. So now this is which approach to the base in both left and right hand sides. Total area of a curve is 100%, which is according to the theory of hypothesis testing. And this is divided into two regions: region of acceptance, region of rejection, and region of acceptance. I will tell you what's the meaning of rejection and acceptance. So two-tailed test we have already understood. If we are not dividing the curve into two parts, if we are studying, taking into consideration a whole part of normal distribution curve, then this will be known as two-tailed test. If we are taking only left tail or taking only right tail for our study purpose, so that whatever the result of one tail comes, we can apply, we can assume that the same will be for second tail as well. This is one-tailed test only. Only this is the difference. Otherwise, this is not a very complicated topic to be taught and to be learned. One-tailed, when entire region of rejection is shown on one end, okay, only on one end, if this is shown area of rejection, okay, then this will be known as one-tailed test. One-tailed test, because we are taking only right-tailed into consideration regarding the area of rejection and acceptance. Rejection and acceptance, still I have to tell you what are these. First of all, I just wanted to teach about the tailed tests. So this is the complete system. So this is the complete normal probability data. Okay, this is the normal probability frequency distribution, and I taught you this concept completely, I think 4 or 5 days back. I told you mean, median, mode are here central at central point, and this curve has two sides, left hand side, right hand side. I told you that the difference of area is calculated on the basis of a standard deviation only. How much this area is far from mean? This is -1 standard deviation. How much area is far from mean? This is -2 standard deviation. This is how this is calculated. And -1 standard deviation plus 1 standard deviation from mean includes 60% of the area of normal probability distribution frequency curve. So this is about this all. Okay, now acceptance and rejection. Suppose I'm going to give you a very clear cut picture. Okay, you have to open your eyes, open your minds now, because this is going to be very important. Okay, suppose a researcher has taken, okay, that confidence level of him being right, okay, that means that, and he is going to do two-tailed test. What he shall do, he shall simply assign this area. Half area here, this side, half area this side, and this area shall be known as area of acceptance. Okay, and now I'll tell you how null hypothesis is true How you can get your null hypothesis is true? When you have found your sample statistics and you apply certain tests to sample statistics like t-test, chi-square, z-test or anything. When you apply these tests to your sample statistics and but the result is that result falls in this area, that means your null hypothesis is true and this is the region of acceptance. And if your sample statistics result on the basis of statistical tables that comes beyond this area is known as region of rejection. Rejection. In this way, we can conclude that our null hypothesis is wrong. If sample statistics falls here, this means your assumption is wrong. In a layman language, I'm teaching you very simply in a very plain language. If your sample statistics falls here or here, that means you are wrong. Your assumption was wrong. Tomorrow shall be rain or not, you are wrong. If your sample statistics falls here, and if it falls here, that means your assumption was right and yes, there will be rain. That means null hypothesis can be accepted. This was all about the concept. Okay, what is two-tailed? This is very simple. If you have divided the area in two tails, this is two-tailed test in which the area of rejection is shown at both the sides, area of rejection. And what is one-tailed test? When the area of rejection is shown only at one side, this is known as one-tailed test simply, and acceptance area is taken to as full, as the full other side, that can be right or left, anything as per the situation. So this was the concept of a complete null hypothesis and the tail test. Now we have to understand about the level of significance. I have spoken many times during this lecture that you are never 100% right about your null hypothesis. You can never say that 100% that there shall be rain, 100% that you shall open some business next year, 100% that the Nifty or the Sensex shall grow. Nifty shall grow up to 20,000 points. Now you can see, if you are aware of the markets, market is at all-time high right now. You can never 100% say that it can be 20,000 point in the coming year. You can never say. You always have a level of significance, and that can be 95%, 99%, 60%, 80%, 90%, 91%, or anything. It can be anything, but it cannot be 100%. If you are 100% sure about something, there is no question of research. And this level, the level at which you can say that I am right, this is known as level of significance. This was all about this. Okay. This refers to the degree of significance with which accept of or reject of a particular hypothesis. So that means if you are 95% sure that there will be 5% chances of you being wrong. Okay, you are assuming yourself to be wrong to the level of 5%. Okay, if you are confident at 99%, then that means you are not confident for 1%. Okay, so that includes the region of acceptance, and that includes the region of rejection. This was level of significance. Okay, since 100% accuracy is not possible in taking decision, we have to take the decision at a particular level of confidence only, and that I have already told you, nothing new. I think you are sane enough because you have listened to me, and I believe that being my genuine and my regular student, you would have understood, because nowadays I know that it's habit of you listening me for recorded or live lectures. Then you always fixed your confidence as at certain level. Like if 5%, that means you would be correct at 95%. If you take at fix at 1%, that means you are assuming yourself to be correct at 99%. This is a very simple process to understand. So if you are wrong, I told you that you can be wrong sometime. Okay, see this again. See this again. I told you that your null hypothesis can be true, but mistakenly you reject it. This is type 1 error. Why do you commit this mistake? You could ask me this question. You commit this mistake only due to that level of significance. Because if you are 90% confident, 95% confident, that then there are 5% chances that you can take a wrong decision. 5% chances are there. And if you fall in that 5% category, then certainly you shall commit either type 1 mistake or type 2 mistake. So this is how the relationship of level of confidence is with the null hypothesis. I think I am getting troubled from somebody. Kindly check if your microphone is on, please. So now I am going to move further. I think this is the last part, and after that only the tests are remaining there, and these are not very difficult. I think 1 or 2 lecture would suffice to teach each and everything. We have already prepared number of items to make you clear about this. This is standard error now. Standard error. This is very simple to understand. Only one example would suffice. Again, remember those 2 circles. This is circle 1, this is circle 2. This circle represents the population. This circle represents your sample. If you find your measures of central tendency or dispersion on the population, that would be known as population parameters. Population parameters. And if you find for the sample, these are known as sample statistics. Okay, this is their name. Okay, and while teaching you about the concepts of normal probability distribution, I clearly made it in your mind that there are only 2 parameters on behalf of which you can find the normal distribution frequency curve. And what were these? These were mean and standard deviation. Mean and standard deviation. These were there. Okay. For population parameter, mean and standard deviation is there. In case of a sample, when you find the measures of central tendency, their name is the same. This is mean for sample, median for sample, mode for sample. But when you find dispersion, when you try to find the standard deviation of sample, this is not known as standard deviation. This is known as standard error. Okay. So for sample, if you are trying to find the standard deviation, formula is same. Formula is not different. Formula is all same. You can go through. We shall deliver you all the notes, and you can go through from these as well. Formula for finding the standard deviation of a population and standard deviation of sample is all same. The only difference is their name difference. For population, this is standard deviation. For sample, this is the standard error. Why error is there? You have to. I teach you very conceptually and in a very detailed manner. I make all your words clear. Okay. Why the name error is there? Okay. This is a population. This is a sample. You take the sample from the population, and there can be number of sampling errors. Number of sampling errors. Mistakenly, you can take those elements in your samples which are not relevant for your study. Which are not relevant. If you have taken the sample of 10 students or 10 people, maybe out of these 10, 1 or 2 are not relevant for your study, and this is a sampling error. Okay, this is the reason when we try to find the standard deviation of the sampling, we term this as a standard error. Okay, standard error, we mean the standard deviation of the sampling distribution of statistics, mean, etc. Hope you would have understood this, and none kind of other lines are necessary to go through. So standard error, simply this is the variability due to chance or random factors. Okay, it is calculated from the sampling distribution of a statistic, sampling distribution. Okay, population distribution is this, sampling distribution is also this, but it is smaller in size as usual. Okay, so this is sampling distribution, and when you try to find its standard error, this will be not standard deviation, that will be known as standard error. Formula is same. When you underroot the variance, this will be standard error. In same in the case of population parameter, when you find the under root of variance, then that will be your standard deviation. So standard errors are different for different statistics. For different types of research, there are different types of standard errors. For mean, this is different. For median, this is different. For mode, this is different. For range, this is different. For quartile deviation, for everything, we can find the standard error. We can find the standard error for every distribution. If we have taken 10 samples, okay, if we have taken 10 samples, and if we try to find the standard deviation of each one, okay, and finally we get only one value of a standard error, okay, this will be known as standard error of your sample distribution, okay. And this can be for any value. This can be for mean, median, mode, range, quartile deviation, percentile, decile, or anything. This can be for anything. And for each and everything, the formula of standard error is different, and this you have to go through. Either you have to cram, or you have to learn, or whatever the way you can do it. You are not supposed to solve it practical, but its understanding is necessary. Understood you have already for all this concept, but the thing is you have to go through from its formulas as well. The reason is two times I have experienced, two times I have experienced in the previous papers that sometimes the options are there, name is there, standard error of mean, standard error of median, standard error of mode, and there are given some formulas like list A and list B, option type question, and you have to match what is the formula of standard error of mean, what is the formula for standard error of median, what is the formula for standard error of mode. So this is only what you have to go through. Otherwise, this topic is already complete. So utilities of standard error, if we read this now, this is very easy for going through. Okay, this only tells us your degree of precision. This is always tell you about the estimation of parameter values through sample studies. Everything is possible only on the basis of standard error. Why? I have already taught you for finding the normal distribution, only two things are needed. This is mean and standard deviation. And in case of sample, this is the standard error. Then it helps in determining the limits. Only from this we can find the limit. You remember I told you this is mean, and this is the difference of -1 standard deviation or standard error. This is the difference of +1 standard error. So it has number of utilities. It determines the limits. Standard errors, you can find this because standard error is everything. It tells you about level of significance, 0.5, 0.1, 0.27 or anything. Then it is inordinately in testing the significance of difference between any independent two samples. If we have taken two samples, how we can get to know that which one is better, which one is performing good, and what is the difference between these two? Okay, these we can find only on the basis of a standard error. Then last, there is theory of estimation. Okay, theory of estimation that tells you some techniques and methods of finding the unknown population parameters. I told you in the beginning of the lecture that there are two circles. The first is population, the second one is sample. Population is there. You can never find the population parameters. Okay, although theoretically is possible, practically it's not possible. You can never find. You can find the sample statistics only,